Hi friends, myself Dr. Buddhadev Sahu. I am working as an associate professor at SR University. This is your lesson number 3, the construction and working of synchronous generator. Because already the induction motor as well as induction generator part is over, now we will start the synchronous generator. Now come to the point, before going to the detail about the synchronous generator, first you see what is that? That is the electrical machine basically divided into two parts, DC machines as well as AC machines. DC machines already we studied in the third semester. Okay, and AC machines that we are now studying in the fourth semester as per our university syllabus. Now you see in the third semester what you studied, basically DC generator, DC motor, these parts we completed. If we specifically see about the machines, these parts already cover. Now in the first unit already cover about the asynchronous machines like induction machines, that is broadly divided into single phase as well as three phase. Similarly, synchronous machines also will focus in the synchronous generator as well as synchronous motor. It is also divided into two parts like single phase synchronous generators, three phase. Similarly, single phase synchronous motor, three phase motor. Okay, now we will come to detail. We will start what is your synchronous generator. First, you see here I am writing by which you can understand. Okay, give a heading of synchronous generator. Okay, first you see in case of synchronous generator, I want to tell you one point that it is similar to the induction motor. The constructional there is the same components is required. In induction motor, what we require? There is one starter, major component is starter, another one is rotor. But what we observe in case of induction motor, the starter contains the field winding. Okay, and if you see here, then uh, in case of the rotor, it is nothing but the armature winding. Okay, and here you see what is the difference, that it is your induction motor. That means you are giving the electrical input, and what will happen, your mechanical output will produce, right? Mechanical output will produce. Okay, now we compare, because our main aim is synchronous generator. Here you see synchronous generator, I am short form I am writing down, that is also component is your starter as well as rotor. Okay, and here you see in this case of starter, if you will see the starter here just reverse, starter here armature winding is present. Okay, armature winding is present, but rotor here contains what? That field winding. That means you see the difference, that what you are giving in synchronous generator, you are giving here synchronous generator the mechanical input. What you are giving? That mechanical input. And what you are getting? That you are getting that electrical output. Okay, just opposite to the induction motor. Okay, now you see one point. If I will discuss more about this, you see one point, that here electrical input you are giving to the starter, and starter will produce the rotating magnetic field. Due to the rotating magnetic field, it will cause the rotor bars, and rotor bar one EMF which induced, that EMF will produce the mechanical output. This is the operation of induction motor. But in case of this, what you see, that you are giving the mechanical input. Mechanical input to what? That is your field winding. Always you are giving the field winding the supply. Then your input is given to the rotor, and the rotor will produce the rotating magnetic field, and this rotating magnetic field will cause the starter bars, and the starter bar will produce the what? Starter bar will produce, or in case of the starter, one EMF is induced, and this EMF will help to produce the electrical output. The process, you understand, that you are giving some mechanical input and you are getting some electrical output. Here you are giving some electrical input and you are getting some mechanical output. That is our basic thing is synchronous generator as well as induction motor difference. Okay, now we'll go in case of the rotor types. Okay, the next slide you see here. What? Give a heading of rotor types. Okay, now you see, if any question will come, the differentiate between induction motor and synchronous generator, you see induction motor, the rotor types are what are the, one is your squirrel cage induction motor, another one is otherwise it is your nothing but slip ring induction motor. But if you see, in case of synchronous generator, the rotor types again similar to the induction motor, it is broadly divided into two types. What is that? That is, you can write here that a salient pole salient pole rotor. Otherwise, you can say it is nothing but your cylindrical rotor, or we can say non-salient pole rotor. Okay, but this will detail understand, because in the previous section we already discussed about these type of rotor types, but here we will specifically focus about the salient pole as well as cylindrical rotor types, because this will help you to understand about this. Now coming to the next, that the construction first you will understand. Okay, in the construction, give a heading of construction of synchronous generator here, that it is nothing but construction of synchronous generator. Now you see, if I will draw the construction, first you see, definitely there is a starter. Okay, and what will happen in case of the starter? What will happen in this case? The slots are present. Slots are present here. That slots, you can say that it is the slots like this. It will be present. You can draw. Okay, because I told that starter contains the armature winding. Starter contains the armature winding. Okay, by the process you see, these are the slots. What we can mark it as a slots present in the starter. This is your outer periphery. Okay, and another one is what? Rotor is the center here, we can say, and the rotor diagram I am drawing here. By the process you will understand here what are the rotor I am drawing. That is basically depends on the types. Okay, the first type I will explain here, that suppose the rotors are salient pole, what will happen? All the, this is the poles and the rotor bars are projected outside. Okay, like this shape. The rotor bars are projected outside. Okay, okay, and you see this is the center, and you can see to wind or to catch the rotor bars, there is one steel spider is there. Okay, I'm highlighting these things. This is the rotor bar, rotor bar projected outside. Okay, And what is that? Across this, what will the damper bars are there? What is the damper bars? I will explain. Damper, you just write down. Damper bars are there. Okay. And another thing, the slots means here we can place the windings. You can place the starter windings. Okay. Hmm. Then other components, what is there? That is, we can say, we can, what is the red color symbol? That is nothing but, that is your steel spider, and spider to catch the rotor bars. Okay. Now you see, this is nothing but, this is the base of the synchronous generator. We can say where the, it is nothing but base of synchronous generator. This is what? This is the shaft. We can say this is the shaft which carries the complete rotor. Okay. Any parts I left? I think no. Okay. These are the parts. Now you see the one by one. Initial part, I just want to explain what is the slot. Slots are nothing but the empty spaces. Empty space. You see, there is some empty spaces are there. Empty spaces, empty spaces. What are they? That means in between these space, you can put the conductors. Then if you are putting the conductors, there is two types of windings generally available. The winding type, if you will see, we will detail discuss in the next class. Winding types. What are the winding types are there? Two types of winding types are there. One is your concentrated winding, and another one is your distributed winding. What? Distributed windings. That keep in mind. And concentrated winding, what will happen in concentrated winding? Suppose this is the metal bar, and across this coil will rotate like this. You see, this is the bar, this is the rotor bars, and you see this metal bar. If the coils are present like this, then we can say this is the concentrated winding like this. Okay. If I will say the distributed winding, if the rotor is like this, the circular rotor is like this, and what will happen, you just place the windings like the conductors like evenly distributed across this. That means if I will draw one line, then what, how many number of conductors are upper side, and how many number of conductors are below side, that upper and below conductors are equal. Okay, that is your distributed windings. Now you see the outer periphery is generally made up of cast iron. And why the cast iron? Because cast iron is more stronger than any metal. Okay. Then you see the starter windings or starter slots or starter core is made up of silicon steel. Okay. And why it is made up of silicon steel? Because it is made up of silicon steel by which you can the best conductivity. Okay. And reduce the eddy current loss. Okay. Now you see the other factor also we will see that here, that rotor bars I will explain detail, you see, but one of the important part is the rotor. And here specifically, if I will say, what is that? That is your salient pole rotor. And salient pole rotor means the rotor bars are projected outside. Okay. Now across the rotor bars, what will happen? Across the tip, some damper bars are there. Why the dampers bars are there? Dampers bars are present across this to eliminate the oscillations. Oscillations, oscillation means disturbances. Can you say why the oscillations will create? There is two factors. You see, if you see the rotor, it is the rotor, the tip. If you see here, then you see the air gap between these two, and you see the air gap between these two is different. That means due to the non-uniform air gap, one point we can say non-uniform air gap. Due to the non-uniform air gap, the oscillations will occur. right? The second point, you see, if you change the loads, because you see you will connect to the load, or if your demand is changing, due to that also the oscillations will create. And to overcome this oscillation, the damper bars generally it is used. Understand? That is the point of damper bars. And why the steel spider? You see the poles, the rotor bars are just pointed outside. That pointed outside means when it will rotate, there it will exert a higher force across this tip. To if across the tip the higher force will exert, there is a chance of break these bars. To avoid this, what we are using, one steel spider we are connecting in this manner, by which it will hold and give strength to the rotor bars. Understand the points of construction? This is the construction, we can say, that of salient pole rotor. But another 2 points also common, that here to provide or to give the supply, what will happen? The another two components are there. One is your process, another one is your slip rings, because these two are also important. And we know the process is made up of carbon, okay, and the slip ring is the conducting material we are using to generate or to provide the AC supply. Okay, now you see the construction of synchronous generator in case of salient pole rotor. This is all about. Now coming to the next part of this, will go like this. What is that? Salient pole structure, why like this? This is very important question. Also people are asking. You see, what is the salient pole rotor? Now you see, in case of the salient pole rotor, you first draw the diagram of the salient pole rotor. This is the bar. Okay. Now the structure is what? Now the structure is projected like this. Okay. Maybe some arrangements like this you can do by. But you see the salient pole rotor, one of the if you will see the one, then here the damper bars are there. What is that? Damper bars are there. And the concentrated winding will present across this. Okay. Concentrated windings the across this. Okay. But now try to understand that why the shape is like this. Then I will explain this one by using three conditions. Okay. Now you see, if I will put one condition like this is the condition, because we know there is the outer part is circular. Okay. Now suppose I will put here some rotor. What? Some rotor bars I will put. Then it will also linearly vary with the outer side. Then what will happen? That we will understand now. Okay. Now you see, if it will like this, suppose we are giving a supply. Okay. And due to this supply, what will happen? You see the air gap between these two. What will happen? This air gap is equal. This is also equal. This is also equal. Means all are equal air gap. Okay. And due to this arrangement, what is the main aim of the synchronous generator? The main of the synchronous generator, that it produce the sinusoidal signal. Then you see, if this type of arrangement is there, then what will happen? Due to the initial condition, what will happen? Due to the rotation of the rotor, this is the rotor, then what will happen? Initially the flux will develop, and after the flux will reach to the rated limit, it will be constant for some time, and after this again it will reduce to zero. The flux gradually it will increase to a certain point, after that it will be constant, and gradually it will decrease. Okay, this is nothing but the flux. But what you require? You require the sinusoidal output, because if you are getting the square or any type of output, you cannot utilize this one. Okay, for that reason, what we can say, we will try some other. This is not possible. Okay, if we are using this now, then definitely there is a problem. Now, second condition. Suppose I will use the next condition, that is, suppose this is the thing, and I will use some square like this type of rotor. Then what will happen? You see, if I will mark, this is the smaller air gap, this is also smaller air gap, but this air gap is larger. That means in this condition, what you can derive, you see, initially it will take some time build up the flux. Due to the larger air gap, the flux value will decrease, and again it will come to like this. And here you are getting a lesser flux. You are getting a constant flux. But what you need? You need a sinusoidal flux. For this reason, you see in this condition, this is your outer side, and if I will put here, what, this is the shape, this you see that this is the shape, this is the shape of the rotor. If this is the shape of the rotor, you see initially the air gap is larger, but here the air gap is small. Here the air gap is again larger. In this condition, you are getting larger air gap, smaller air gap. But you see what will happen, the output what you are getting, that initially it will build up the flux, but due to the lesser air gap, the flux will like this. Okay, the flux will be more. Okay, and what will happen after some time, again the air gap will increase, you are getting the flux is like this. Similarly, the alternative position, you will get the flux will like this. But you see what you are getting now, the flux will become that phi m sine omega t, and from this we know that that flux is directly proportional to current. If flux is sinusoidal, the current is also sinusoidal. Our objective is now complete. By using this type of design rotor, you are producing the sinusoidal current. Okay, this is the point you can understand, that why we are using this salient pole rotor, and why the structure of this salient pole rotor is like this. It is very important point. Okay, keep in mind. Now the next point, you see, if you I will give a next heading, that is your cylindrical rotor, cylindrical rotor. But one point keep in mind, in case of salient pole rotor, the pole can be varied. N number of poles we can use. As your requirement is more, then you can use more number of poles. But cylindrical rotor, what you can say, you can use either 2 or 4. What? 2 or 4 number of pole, not more than that. Keep in mind, use either 2 or 4 number of pole. Now you see cylindrical rotor, how it will look like. You see, this is a circle, means the rotor. Okay, and what will happen, suppose I will put how many number of pole, north pole, one pole here, and another pole here. This is the suppose second pole. Okay, this is first pole. Then maybe there is this is the two number of poles are there, and you can produce the magnetic field, means it may possible. Otherwise, if you need more magnetic field, what you can say, that this is the one pole, you can mark at each a north pole. Then there is another pole, that is 1, this is the 2, this is the 3, and this is the 4. Okay, north, south, then again north pole, then again south 4. 1, 2, 3, 4. But the point you see, if these are the poles, we can say this is the rotor, how many poles are there? Four poles. That means I told here we can place the conductor. Here is suppose you are putting two conductor, here two conductor, here two conductor, here two conductor. Then how you can make? You see, if this is the input current direction, north to south the current will flow. That means this is the output current direction. Then again this will be the input current direction, then this will be the output current directions. That means the complete circuit will over. And in between this, what will happen? The shaft will present, and across the shaft, what will happen? The slip rings will present, and the slip rings will connected to the brass 1 and brass 2. It is the front view. If you will see the side view, then this is the cylindrical rotor, and this is the uh, rotor, and you see the rotor north pole south pole like this, it will present like this. Okay, and the same structure you can do north pole south pole, here north pole south pole like this. Okay, and here one point you can see the diameter of this one is less, d equal to less. But if you see the axial length will be more, what? The axial length will be more. Okay. Now you see this is what? This is the shaft. We can say this is the shaft, and here we can use the shafts are there, and you can say that if slip rings are there and the brushes, this is are the brushes B1 as well as B2. Okay, now the point you can keep in mind, the construction is same. Okay, the cast iron as well as the you see shaft contains the complete weight of the rotor. That means the shaft is made up of mild steel. Okay, keep in mind. And used, everybody know that we are using the silicon steel to reduce to improve the conduction and reduce the hysteresis loss. And everybody know, until from the starting we are in DC as well as induction motor. Again, if you are coming to the synchronous generator, everywhere we discussed that we are using the laminated core. And why you are using the laminated core? To reduce the eddy current loss. That you can clearly write here, that to reduce the eddy current loss. Okay, eddy current loss, we are using what? To reduce the eddy current loss, you are using that sorry, mm, laminated core. Okay, another important point, if you see that in case of this salient pole rotor, we are using the damper bars. Damper bars, why it is used? Because you are getting non-uniform air gap, but you are using in case of cylindrical rotor as the uniform, because you see this is the rotor outside. If starter will be there, then you see this is the starter, then everywhere you are getting the uniform air gap, and due to the uniform air gap, the damper bars is avoided in this section. Okay, keep in mind these things. Now if you broadly classify this difference between salient pole as well as cylindrical, give a heading of this one. This is very important, that is salient pole rotor, another one is your cylindrical rotor. Keep in mind thing. Then here you see in case of salient pole as well as cylindrical rotor, the first point you see, what I can say, non-uniform air gap is there. Non-uniform air gap. Okay. And in cylindrical, now only I told, that is your uniform air gap. Okay, is there. Second point you see that second point, that here damper bars are there. Damper bars are there to reduce the oscillation. Okay, and here not there. Okay. Then third point, you see the diameter is more and the length, axial length is less. Length equal to less. But in this case, what we can say that the diameter is less, but the length will be more. Okay. Then third point, you see it can be applicable for lower speed, for lower speed. And you can say the speed will lie between 100 rpm to 500 rpm. And here it can be used for higher speed, that is also it is in between 500 to 1500 rpm. Keep in mind. Okay, now you see another point also we can note down here, more poles we can put, and but here due to this what we can say that less poles. And how many poles that I already mentioned, 2 or 4 poles we can use. By the process, you see this cylindrical rotor is more advantageous. And here another point we can mark out that here distributed windings we will use, and here we are using the concentrated winding. Okay, two are different windings, and when I will discuss more about this armature windings, I will clearly explain about this. Okay, now you see you are getting a broad idea about the rotor types, how the construction of the synchronous generator will operate or designed. Then this distributed winding types I will explain later. For that, next what we will understand that working of synchronous generator. Then before going to working, now you see what is the important parts. The first I explained, one is your starter and another one is your rotor. That keep in mind. Okay, one is your starter, another one is your rotor. And in bracket if I will write, starter contains that armature windings. Okay, and rotor contains what, that are field windings. That if you will see in case of, if you remember in case of induction generator, that always we are giving the supply to hood, that field windings. Then here we are also giving the same, that we are giving the supply to the field winding. Try to understand, I'm giving the supply to the field winding. Then you can see here I'm putting a star mark, I'm giving a supply. Which supply? It may be DC or maybe AC, because what you are giving the supply, that depends upon the your requirement. But first I am putting some DC supply. What? DC supply is given to field winding. Then we know that a DC means what will happen, the DC will produce the constant voltage, constant plus or minus, that is your voltage is constant. And if DC supply is given to the field winding, then what will happen, this supply is your constant, V is equal to constant. Okay, supply voltage. And if we are giving that supply voltage is constant, then definitely the constant magnetic field will produce, constant magnetic field will produce. Okay, if the constant magnetic field will produce, then one point you see this magnetic field is constant. That constant means it will not rotate the rotor. Yes or no? If it is a variable magnetic field or rotating magnetic field, then only the rotor will rotate. But we need the RMF. RMF is required to rotate the rotor. But the question is how RMF will produce. This rotating magnetic field, in case of induction motor, it is produced because you are giving the three-phase supply. But here you are not giving the three-phase supply. That's why you are giving a constant DC supply. That means you are getting a constant magnetic field will produce. Okay, then how you can make this one to rotating magnetic field? This is the question. Then, to produce the rotating magnetic field, you need a prime mover. What? You need a prime mover. Okay, and prime mover, you see how you can connect this DC supply. The DC supply is given to this rotor by using brass and slip rings are there. Okay, and you need a prime mover. Now you see this is the shaft. Okay, and by giving this as there is the brass is there, through the brass you are giving the supply. Okay, DC, then due to the DC constant magnetic field is produced, but you need a rotating magnetic field. Then what you will do, this rotating magnetic field, how you will produce? You need a prime mover. Prime mover, what it will do, it will rotate the rotor, and this prime mover when rotate the rotor, this constant magnetic field will convert it to rotating magnetic field. If this constant magnetic field will convert it to the rotating magnetic field, this rotating magnetic field will call the starter conductors. And if the starter conductors, this rotating magnetic field will cause the starter conductors, then what will happen? One EMF is induced across the starter. Okay, and if the EMF will induced across the starter, this electricity is produced. What? Electricity is produced. But keep in mind, this electricity is produced due to the activation or due to the utilization of the prime mover properly. Okay, then what will happen? Your electricity is produced. But the question, there is another question, why DC supply? Okay, that for that reason also I am explaining the point. There is actually two types of exciter. What is that? You see here that I have mentioned that why, then there is a question why DC is required. Maybe we can use the AC also. Then what is the solution? There is two type of exciter is required. What is that? DC exciter. Another one we can say AC exciter. What is required? I am saying. Okay. In case of this, if you see the DC exciter, what we can say, DC exciter is nothing but there is one main exciter which is used to excite the rotor. Another one is your auxiliary exciter. And in case of this auxiliary exciter, we can use the permanent magnet to excite the main exciter, and the main exciter will excite the rotor. But in AC exciter, you need an additional alternator. Okay, and this alternator is produce the three-phase power generation. And if the three-phase supply you are giving to the rectifier, then what we can say, this will produce the what? This will produce the DC supply, and DC, if it will generate, then you can use the DC supply to give the field windings. This is our objective. That means you see the DC exciter is more simpler and easily, if you are using any battery or any something DC source, then what we can do, we can easily start your synchronous generator. But if you see the AC exciter and the process, the complete process will take a much more time. That is the reason we preferably use this DC exciter. Now the practical example I am giving where you can use the synchronous generator. Practical example. Now you see, suppose everybody know about the dams. What dams? Dams means this is the place where we can store the waters. Okay, this is the water levels, right? What we can say, waters. Then suppose someday what will happen, rain will increase. Then what we can say, just rain will increase. Then what will happen, this water level will increase also. You see, this water level will increase. But suppose I will fix my synchronous generator here. Okay, this is what my synchronous generator. Now you see, if synchronous generator is kept here, I know that synchronous generator is having the shaft, and in this shaft if I will put some what I will put, some turbines like this. Okay, this is the what turbines I am keeping. Okay, blades. Then what will happen, due to the excess rain, what will happen, the due to the excess rain, what will happen, the water flow will increase and it will fall on the this turbines, by which the turbine will start rotating. What, the turbine will start rotating. But the one point you keep in mind here, as a synchronous generator is there, you need a supply. What is that? If you are having some battery or DC supply, you just energize the synchronous generator, then it will produce the constant magnetic field, and by this natural process you are getting some some rotation. Means this natural process will act as a prime mover. That means suppose in a bigger machines, you cannot control that one. That's why you need a natural resources. This is your natural resources by which you can control the speed. Okay, and or we can rotate the turbine. By the process, what will happen, synchronous generator will generate some electricity, and you can utilize for the grid integrations, right? That you keep in mind, that grid integrations. This is the practical example of synchronous generator. Thank you very much for your attention, and thank you very much for your patience also. Then in this class, what are the outcomes of this? I just want to tell you. One, you understand what is the basic difference between induction motor as well as synchronous generator, and where you can use the armature winding, where you can use the field winding, everything I explained. Another thing, what are the rotor types? Basically it is found in synchronous generator, that also we discussed. Okay, and the working of synchronous generator, very important things you can note down in the stepwise manner. That is the all about, and practical example also there. Anytime you can go to the any industries or any dams, you can see this type of synchronous generator which is used to produce the electricity. Thank you very much for your patience.